23 to 27. It says you buy a bag of Starburst candies and a bag of Jolly Ranchers, and the bag of Starburst candy has 80 pieces and 12 of them are cherry flavored, and then the bag of Jolly Ranchers has 70 pieces and 14 of them are cherry flavored. Okay? Assuming that these are truly random assortments, does this provide evidence that Starburst and Jolly Ranchers have a different proportion of cherry flavored candies? Okay. All right. Does that make sense? We're trying to know, you know, because everybody loves cherry, right? No, I don't know.
Yeah.
No, maybe not. Strawberry. The reds are definitely better than the yellows, though. Okay.
Oh,
Yeah, right. Nobody gets excited about a bag of yellow Starburst. You do?
I mean,
Is it
the
your
lemon
favorite?
one.
The lemon one is your favorite? Okay. It's not my favorite. All right. Okay, so it says for a hypothesis test, all right? Are we dealing with proportions or means? Proportions, okay? And do we have one sample or two samples? I've got two samples, okay. So what are my hypothesis tests for a hypotheses for a hypothesis test for two proportions, okay? Two sample proportions. Okay? My null hypothesis will always be P1 equals P2 or P1 minus P2 equals 0, all right? That's going to be the null hypothesis for whenever we have two sample proportions. And my alternative is going to be P1 minus P2 and then something 0. Am I going to put greater than, less than, or not equal to?
Not equal to.
Not equal to. Because the question says, is this evidence that the proportions are different? Okay? Do they have different proportions of cherry flavored candies? So we're putting a not equal to sign there. Alright? And notice we're using P's, not P hats, not mu's, not other things. These are P's. P's for proportions. Yeah?
Wait, why did you not equal to? Because it says why?
Because it says, does this provide evidence that Starburst and Jolly Ranchers have a different proportion? And the problem says different. Okay, and it's not asking, is this evidence that Starburst has more cherries, or is this evidence that Jolly Ranchers have more cherries, or Starburst has less, or Jolly Ranchers have less, or something like that. Okay. Okay. 24. What is P hat? P hats are combined proportion, okay? So in this case, it's going to be 12 plus 14 over 80 plus 70. Yeah? Yes?
Is it okay to just write P1 minus P2, or do we have to name it like P Jolly Rancher, like you did?
Oh, P1 and P2 versus P Jolly Rancher and P Starburst.
Yeah.
Either way is fine, okay. I think on the final, I'm just going to have 1s and 2s.
Oh,
But-
because it's multiple choice.
It's multiple choice, right. I mean, if you wrote 1 or 2 or Jolly Ranchers and Starburst, that's fine, okay? I can generally understand what people are doing. But it'll be multiple choice, and so you'll see some choices there. All right, so here I get 26 over 150. What is that about?
0.173.
Huh?
0.173.
0.173. Okay, great. So that's 24. And number 25 says, what is our test statistic? Okay, so in this case, we're going to have P1 hat minus P2 hat minus 0 over our standard error. Okay, this is our observed difference in proportions that goes on top. And we're going to divide by our standard error. So our standard error, what is our standard error? I'm going to continue 25 up here. So my standard error is going to be the square root of P hat times 1 minus P hat over 1 over N1 plus 1 over N2. This is going to be 0.173. 1 minus 0.173. 1 over 80 plus 1 over 70. Okay? And then square root of this. Alright, again, to do it on your calculator, you're going to punch everything all on the inside all at once and then hit the square root answer button on there. Alright. So let's see, 0.173 times 1 minus 0.173. Over 80 plus 1 over 7. Okay, I'm getting 0.062. Point 0.619. 0.062. That's fine. I'm pretty sure I punched it incorrectly. Okay. So this is the standard error. We're not done. Our test statistic, it's a z-score. It's going to be P1, which is 12 over 80 minus 14 over 70 divided by 0.062. Okay, 12 over 80 is 0.15 minus 14 over 70, which is 0.2. 0.062. I have negative 0.05 over 0.062. So if I do this, I get negative 0.808 or negative 0.81. That's my z-score. 25. This is our test statistic. Negative 0.81. 26. Perform a hypothesis test, and what is the p-value? Okay, so here I look up negative 0.81 in my z-table, and the area to the left of that is 0.2090. I have a two-sided test because the alternative has a not equal to sign. Okay? So it's a two-sided test. So that means I have to double it. Okay? So my p-value is going to be 2 times 0.2090, which is equal to 0.4180. Okay, this is my p-value. Number 26. And then lastly, 27. So based on this p-value, what is the conclusion I make? Do not reject. Okay, our p-value is bigger than alpha. Okay, it says alpha is 5%. We have 41.8, 42%, which is bigger than 5%. So we do not reject the null hypothesis, and that means we do not have evidence that the proportion of cherry candies is different for the two companies.